In this session today, we're going to look at sequences and series, and we're going to start off basically with just a very basic sequence, and we're going to start with a thing called a recursive formula. And what that means is that when we deal with a sequence or a series and we have a recursive formula, the formula gives us the first term, and it's going to tell us that each preceding term after that is going to depend on the previous term for its value. That's what recursive means. So we'll have to know the previous term in order to get to the next term, basically, is what I'm trying to say. So in this case, we're given the first term a sub 1, which in this case is equal to 2. We want to find the first 5 terms of the sequence. So we already know that the first term, a sub 1, is equal to 2. And one other little side note here for us as we're looking at this little subscript here, all that does is indicates which number of term we're talking about. So don't get distracted by the little subscript. It just tells us which one we're talking about. That's all it does. And it's going to come into play, especially here in our formula. So I'll show you what I mean by that. I'm going to go and find the second term. So in other words, in this first term, n is going to be equal to 1. In the second term, when n is equal to 2, then that means my a sub 2, and that's how I say that with the subscript, a sub 2, the second term of the sequence, is equal to 2 times a sub 2, and notice I'm substituting in 2 where n is, minus 1, and again, this subscript notation only indicates which term I'm talking about. That's the only significance it has. So a sub 2 minus 1 plus 1, subtract 5. Now I want to show you how this subscript comes into play here, because this is where students get confused a lot of the time. So let's go simplify that. My second term, a sub 2, is going to be equal to 2 times, and notice 2 minus 1, so that's going to be a sub 1. So what that's saying is that my first term is going to go in here, the value that I got from my first term. And remember, that was 2. I'll substitute that in here in a minute. I'm going to go ahead and finish out the equation or the formula. All right, now I make the substitution. I'm going to take this value and I'm going to put it in here for a sub 1. So a sub 2 now is going to be equal to 2 times a sub 1, remember, is 2, plus 1. Subtract 5. And then we're going to finish this out. So my second term, a sub 2, is equal to 2 times, remember, order of operations, I have to do what's in parentheses first. 2 plus 1 is going to give me 3. Subtract 5. That's going to be equal to 2 times 3, which is 6, minus 5. That's equal to 1. So my second term of the sequence, a sub 2, is going to equal to 1. Again, don't get lost in the subscript notation. Now I want to go on to the next term. When n is equal to 3. So again, I go with the notation. That means I'm finding a sub 3, the third term of the sequence. That's equal to 2 times a sub n minus 1 plus 1, subtract 5. Again, the subscript. And I'll get away from this in a minute. I just want to make sure we got it. I'm going to substitute in for n. So that's going to give me 2 times a sub 3 minus 1 plus 1, subtract 5. So carrying out the equation or the formula, it's going to be equal to 2 times. Again, all this does is tell me which term I'm talking about. I do 3 minus 1, which is 2. So it's saying the second term, which was the previous term before the third term, or a sub 3. That's all that does is tell me which term I'm talking about to substitute in. So now remember, my a sub 2 up here was equal to 1. So I substitute that value in. So it's going to be 2 times a sub 2 was 1. 1 plus 1, subtract 5. And then again, I have to do order of operations to evaluate and simplify this. So I do what's inside the parenthesis. 1 plus 1 is 2. So that's going to give me 2 times 2, subtract 5. 2 times 2 is going to be 4, subtract 5, which is negative 1. So that tells me that a sub 3, my third term in the sequence, is equal to a negative 1. Okay? All right, so it asks us to find the first 5 terms of the sequence. So we're down to term number 3. Now we need to go to term number 4. So n is going to be equal to 4. So that means a sub 4, my fourth term, is going to be equal to 2 times a sub 4 minus 1 plus 1, subtract 5. Again, I got to evaluate that subscript. So that's going to be 2 times a sub 3, which was my previous term. That's why it's called a recursive formula, plus 1, subtract 5. So that's going to be equal to 2 times, my a sub 3 was negative 1, so negative 1 plus 1, subtract 5. That's going to be equal to 2 times, negative 1 plus 1 is going to be 0, so that's 2 times 0, subtract 5. And of course, 2 times 0 is 0, subtract 5. So that's going to give me negative 5. So therefore, my fourth term, a sub 4, in the sequence is going to be equal to negative 5. All right, I have one more term to find. It says to find the first 5 terms. So I got to find the fifth term now. That means n is going to equal to 5. So I'm finding a sub 5, the fifth term, is equal to 2 times a sub 5 minus 1 plus 1, subtract 5. So that's going to be equal to 2 times a sub 5 is going to 5 minus 1 is going to be a sub 4. And again, that was my previous term right here. I'm going to substitute that in the next step. So that's equal to 2 times, remember my a sub 4 was negative 5, so it's going to be negative 5 plus 1, subtract 5. So that's going to be equal to 2. And then I do what's inside the parentheses, do an order of operations. So that's going to be 2 times a negative 5 plus 1 is going to give me a negative 4, and then subtract 5 from that. That's going to be equal to 2 times a negative 4 is a negative 8. Subtract 5. Remember, when the signs are the same, you add the numbers and keep the sign. When the signs are exactly the same, in this case it's going to be 8 plus 5, which is 13. And then it's going to be negative because both those are negative, so it's going to be a negative 13. So my fifth term of this sequence is going to be a sub 5 is equal to a negative 13.